Hello and welcome to our second lecture. Still a review lecture. We are still recapping the key factors that you need prior to entering into Algebra 2 or the second half of Algebra. We're obviously not going to cover it all from beginning algebra or from Algebra 1, but we do want to get a recap of the most important points that are going to be coming up immediately in our Algebra 2 course. The first exposure that we had to algebra was this concept of a variable. The most popular variable is x. You guys remember from my last video? It's probably why we don't use multiplication. It's probably why we don't use an x anymore to symbolize multiplication, because x is the most popular variable in algebra. X stands for some number. X plus 2 is some number plus 2. And in your first algebraic situations, you were given the value of x. You were given x is equal to 4. So you'd plug that value into x, and you would have 4 plus 2. 4 plus 2 is just equal to 6. So hopefully nothing crazy there. Hopefully that's some gentle review. Let me give you a tougher one, slightly tougher. All right, let's go with, this time I'll use y as my variable. Y minus 7 squared. And this time, y is going to equal 9. So we'll take our 9, we'll plug it in for y, so we'll get 9 minus 7 squared. Do the parentheses first. PEMDAS, order of operations. Do the parentheses first. You're left with 2 to the second power, or 2 squared, or 2 times 2. 2 times 2 is just 4. So these were your early examples. Plugging into the variable, plug and chug, as I was originally taught back when I went to high school. But you plug it in, you chug it out, you stick that number into the variable, and that value for that new number is the value of that variable. Early algebra, you were given that value, but it gets more complicated. After you were given that value, you were then given equations. Equations just mean something is equal to something else. Let me start off with some basic stuff that you guys will agree is an equation that doesn't use any variables. If I got let's say $2 here, and then I add $3 there, that's the same thing as having a $5 bill. Anyone who sees this, like, yeah, 2 plus 3 is equal to 5. Yeah, that makes sense. 2 plus 3 is 5. 5 is equal to 5. Yeah, very good. Nothing crazy there. But that concept of equality is something that must be maintained. The way that we maintain it in an equation is you make sure that whatever you do to this side of the equation, you also do to this side. What you do to one side of the scale, you have to do to the other side of the scale to maintain balance. You can take away from one side, just take away the same amount from the other. You can multiply one side, just multiply the other side by the same amount. You can divide one side, just divide the other side by the same amount. You can subtract, add, divide. Whatever you do, as long as you do it to both sides, as long as you keep this scale, like think of this equal sign like a scale, as long as both sides of the scale are equal, as long as you put in to both sides the same thing and you maintain that balance, you can do whatever you want. Let me show you again without variables. 2 plus 3 is equal to 5, 5 is equal to 5. I can subtract 1 from this side as long as I do it from that side, because 4 is equal to 4. And I can multiply this side by 2 as long as I multiply that side by 2, because 2 times 4 is equal to 8, and 8 is equal to 8. I can add 2 to this side. As long as I add 2 to that side, I'll be left with 10 is equal to 10. And what am I missing? Divide. I can divide this side by 5 as long as I divide that side by 5, because 10 divided by 5 is just 2. and 2 is equal to 2. So, just some examples. What about examples with a variable? Examples of equations with a variable, with one single variable. I'm going to go with x, because that's what the standard expectation is. I'm going to go with x for my variable. I'm going to say x plus 4 is equal to 9. Some of you guys might see this and say something plus 4 is equal to 9. And you're just naturally going to get there. Just like, oh, that makes sense. 5 plus 4 is equal to 9. And some of these examples are going to seem elementary, but please pay attention to my methodology. Look at how I solve it algebraically. I know the answer is 5. You might know the answer is 5. Let me show you the process, the formal process, and how to get there for the more complicated stuff when it gets more difficult and we can't just automatically know. The algebraic method is the opposite of PEMDAS. It's isolating that variable. So you'll start off with the bottom of PEMDAS. You'll start off with adding and subtracting. So what is being done to this x? This x is having 4 added to it. And I need to solve for what that value of x is. Yeah, I know, x is 5. Forget about that for a second. I want to know what x is equal to. What is it equal to? If I want to find out, I have to get x by itself. Currently, it's having 4 added to it. I can't have that. I want it by itself. Minus 4 to that side. But wait! I can't do that unless I do this too. Because what I do to one side, I have to do to the other. X plus 4 minus 4 plus 4 minus 4 is just 0. You'll be left with x plus 0 is equal to 9 minus 4, which is 5. Or x is equal to 5. Another example. Five x is equal to 25. Once again, you're seeing 5 times something. 5 times something is equal to 25. And you're like, yeah, 5 times 5 is equal to 25. It's not hard. Again, just stick with me on this process, just real quick. We're going to divide this side because this side is x is being manipulated by 5 this time. This time it's being multiplied. Instead of having something added to this side, it's having something multiplied. And I want to undo that. I want to undo x being multiplied by 5. And the opposite of multiplying is dividing, or multiplying by the multiplicative inverse. But forget about that for now. It's more advanced stuff. 5 times x is equal to 25. Well, if I want to get rid of the 5 times, I got to divide by 5. And I'm allowed to do that as long as I do it to this side too. Because what I do to one side, I have to do to the other. All right. I got 5x divided by 5. Well, 5 divided by 5, any number divided by itself is just 1. So we're left with 1x. For those of you guys like 1x, we don't actually write 1x. I'll say this a lot. Mathematicians are lazy. The 1 is implied. We just write x. X is equal to 25 divided by 5, or x is equal to 5. One more example before I get it complicated on you. We've had one-step equations. Now, those are one-step solutions. You take one step, you multiply, you subtract, you add. What about this one? Oops. I'll use a different variable this time. I'll use y. Y divided by 2 is equal to 7. I want to get that y by itself. To get it by itself, I have to do the opposite of what's being done to it. No, 2 isn't being added. It's not being subtracted. It's not being multiplied. 2 is being divided. How do I undivide? Well, the opposite of division is multiplication. So if I want to get rid of divided by 2, I have to multiply by 2. And that'll multiply in, and that'll get me 2y over 2. And the 2's will cancel. And I'll be left with y equals, but wait a second, if I multiply that side by 2, I have to multiply that side by 2 as well. So y equals 14. Another interesting bit here is you can always go back and check your solution by plugging in your answer into the original problem. So the original problem was y over 2 equals 7. Well, if I plug in 14 for y, I'll get 14 over 2, which is indeed 7. All right, let's do a two-stepper. Let's do a two-stepper real quick. A two-step equation. We're still just working with one variable, but this time there are multiple things being done to it. If you're here for Algebra 1, go somewhere else where this can go a lot slower. This deserves time to be explored and for it to be digested. But this is hopefully a recap for the Algebra 2 folks coming here for just a quick review. This time for my two-step equation, I'm going to go back to x. 8x plus 7 is going to equal 23. Now you see that, and you might be like, I don't even know how to start to understand that. Some of you guys might actually already have the answer too. You might see it as well. But let's do it algebraically. 8 is being multiplied towards x. 7 is being added to 8x. Here's what I want to do. I want to make this simpler. I want to get rid of the 7 first. And if I get rid of it on this side, I have to get rid of it on that side. All right. That's my first step. My first step has those 7s cancel out because 7 minus 7 is just 0. So I'll be left with 8x is equal to 23 minus 7, 16. One last step left. Some of you guys might see the answer now. I got to divide this side by 8 for those 8s to cancel, which means I got to divide that side by 8 too. 16 divided by 8x is equal to 2. Now, that is where we're going to leave it. Just a quick intro, a quick review of the introductory elements of algebra. When we come back, we'll finish up algebra and we'll set the stage for Algebra 2 to take over. But yeah, what we just covered today was one-step equations, two-step equations, concepts of variables, plug and chug. If you have any questions on any of that, look up another YouTuber, another math YouTuber. There's so many great options out there. Definitely check them out. Bye. Thank you. Cheers.